So the next big change was the particle system, which we can show off in a nice little video here. Ta-da! So the nice part about this particle system is there's actually, all that you see right here are all actually the same objects under the hood. They're just being drawn with different data, which this allows us to do a lot more hardware instancing and render this a lot more nicely. Instead of having like tons of every emitter having their own data, all of these are actually sending requests to spawn data. So what are you actually looking at there? What you're actually seeing are 4 particle emitters. So you go to Game Objects, close all this, boop. Particles, you see a particle emitter. Particle emitter is the user front end, where they could say spawn particle burst, or overloaded function with different parameters for the specific number of particles. You could say start spawning bursts repeating, stop spawning the burst repeating. Change what particle you're using. Set the particle position, velocity, acceleration, the tint, or the lifetime. What this actually does is it's setting all that data into this particle burst data object. Which, remember this guy, you'll see him appear in the engine a lot. So you have the min and max of the position, min and max velocity, acceleration, and all the tints. This allows us to take the same texture, but like change the color of it slightly. And then the particle lifetime, the name of the texture it's using, the number of particles, and the particle name. And then all it does is then sets that data, and then ships that data off to the graphics scene manager. We'll explain what that does in a second. But for now, that's all it's doing, is the spawn particle burst just ships off that data. So if you say spawn particle burst overloaded, it just sets your specific data and spawn particle burst. If you want to spawn it repeating, it registers into the particle emitter manager, which is literally just the alarm queue. Second guy up here again. I'll touch on him briefly. He's not a huge change worth mentioning. I can't remember if I mentioned him in the previous video, sorry. So, alarm. Alarm manager is just using that new queue array priority float to then say, alright, do I have alarms to pop? If not, or if true, check how many, the one at the front, if it's past the current time, pop them off, triggers alarm, then register, you just push them in. Deregister, you remove them. Particle manager does the exact same thing. I split these for debugging purposes. If the user wanted to create alarms, I don't want their alarm manager being cluttered up with this particle emitter manager. Like, they shouldn't even need to worry about this guy. So all he does is basically just an alarm queue for the particle emitter specifically, and every time they trigger their burst, they just spawn another particle burst. You'll see this function gets spawned. This function gets called a lot. So where is this going? So we go into the particles on the graphics side. That is being dropped off at the particle manager. Before we go too deep into it, particle manager again is the resource pool of particles, a resource pool of particle bursts. This one is, you'll notice he's not a template. For debugging purposes, I made him, basically just took all that code and copied it into an actual class, because it's a lot cleaner, a lot easier to debug, step through. I like this. Long run, I'm going to start doing this with all the resource pools, just removing that template code, because template code is just a pain in the butt and not nice when we don't have to use it. So, you notice the queue array priority float again over here. This idea of particle type, and then a queue of the commands. So when you push particle burst request, it takes that particle burst data that you saw in the particle emitter and puts that into a command. And then we're going to start with the DX12 because DX12 is a little bit more simpler because DX11 is split into 2 tasks. So DX12, the very first thing you do is remove all the dead particle bursts, which we'll get into what that is in a second with the next one. Process particle burst requests. You pop that command that has that data again. Go to your particle burst pool, pop one off. initialize them with that data, that same data object. You'll see this happen a lot. Initialize with burst data. For the particle burst, all it does is grab the name. Spawn particles, which, because again we only have so many particles, it will try to fill as many particle requests as it can. Otherwise, it'll throw a warning, which you can turn off. This is part of the engine utilities class. So engine settings. It's going to throw a warning here. Enable warning log. You can turn them off if you want, which is actually off in this case. The current implementation is kind of hefty because every time you throw this, it will throw a command. So these commands stack up really fast. Not intentional, but it is annoying, as a good alarm or a good warning should be. So it spawns as many particles as it can. Again, initialize them with the particle burst data, which I'll get into in a second what that's actually doing. And then takes that particle burst, puts it into a particle type, which I'll explain when I get to the rendering. And then takes that particle burst and puts them into the alarm queue. So you see this alarm queue again. It's the exact same idea. But so this allows us to see if entire bursts are dead. So if one burst dies, he can take all the particles with him. So if your burst is only one particle, he'll take one particle. If it's 1,000 particles, 1,000 particles will die. Just whatever your particle emitter says are the current settings. So back to our DX12. So now we get into this, the idea of the particle types. You're doing compute and render on all the particle types. So in our load resources, we actually have the user declaring what types of particles they're going to create. This is the particle name, which is entirely user defined. In this case, is water, earth, air, and fire. The number of particle types, and then you have to say the number of particles and the number of particle bursts that will be created in memory. Alright, and then you take these settings, go back to your load resources. Model manager is basically always going to be the particle model. I don't know of a case where it wouldn't be, but if you want to get fancy, you can. Take your texture manager and give it the texture, which is entirely user defined over here as well. You'll notice here, loaded here, whiteparticle.dds, and the number of particles you want to be associated with that type. So, why are we doing this? So we actually go through all the arrays of your particle types, which were created in that function by the particle setting manager does allocate particle memory, which goes to all the particle managers, and we'll go to that array and create it. So that function call and load resources allocates all the memory for all the particle types that you want. And when you actually go to render it all, you go through all your array of particle types, compute and render DX12. And this particle type will have a list of particle bursts. And then inside of that guy, when you compute and render him, he will have a list of particles. His current particles. So now we finally get to the particles. So remember, when you render, it goes from particle manager to particle type to particle burst to particle. So, first off, the particle here is just a huge block of data. These are used for the billboarding math. The velocity, acceleration, and then here's some of the GPU data, like your world, your tint, your texture, a bunch of padding. But so you initialize all that data by, again, you take that particle burst data and you initialize your position. So see, you take all that graphics data, all the particle data, and you set it equal to a random value off that particle burst data that you gave it. These random functions I created this quarter, they're all based around C++ rand, which I know is not great, but it does the job for now. So we have a whole series of functions of rand int, rand float including negatives. Nothing too fancy there. So then it sets all of its memory, or all of its data here. Now when you actually go to render it, so compute DX11, when that's called, or sorry, compute DX12 is the one we're using, you update your position by applying your acceleration to your velocity, then applying your velocity to your position, and then billboarding yourself to face the camera. So that's just the raw computing power. And then in our case, this is a change Emline made. We actually sort our particles from furthest to the camera to the closest, because this actually will look nicer with the nice blending that the particles do. Is when they're placed on top of each other in order, they look better. And so that's why this is a little bit different than what you might expect. So compute just does the raw math. The DX11, as I mentioned before, just the compute does the raw math. DX11 is split between the compute and render, and there's where you can actually see the actual functions for that. So particle type is where you actually see that work going on for the sorting, which again, is using the Q-array priority float. We're probably going to change this in the future. This was a last second addition where Emline realized that this is actually a huge deal, and it actually looks way better, and I'm glad that they did it. Where you sort all your particles based on how far they're away from the camera, and then you render them all. So, Particle Manager goes through all the particle types, who go through all of the assigned particle bursts, who go through all the assigned particles. So split into 4 categories of Particle Manager: type, burst, particle. And each one holds like a certain bunch of information. Particle type holds the model and texture data. Particle burst holds the particle name and the number of active particles. He's mainly there so you can kill your particles in groups. And your particle is where all that raw computing memory does. All that, just that raw computation is done. And then again, all these are all stored in arrays on the Particle Manager, so it's actually nice and contiguous. So what this allows us to do is in our particle demo scene, the user will create a particle emitter using the current scene, the scene name, which is just the scene that creates it, and the name that they created. And then you can go into particle emitter, set the position, velocity, acceleration, set the burst lifetime, and then start spawn burst particle repeating, say 40 particles every 0.01 seconds. And then we take another emitter, set his settings. We're going to give this guy a little tint to make him look different. Again, set burst repeating. This guy has another different slight tint, burly wood. This guy, white smoke. So by creating those 4 emitters that are all sending those particle data requests over to the Particle Manager, all of those particle objects that you saw over there are all just being rendered here in different contexts. So we're reusing a lot of data here. All the particles you see from these 4 emitters are all the same object, just using different particle types and different tints, which gives that the nice, they're all using the same texture. I think it's the red one is the one that's actually the original. Yeah. Light blue, brown, and white. Yep, so the red is the actual original texture, and the others are just tints off the original one. Ta-da! So, the user side of the particle emitter doesn't actually own anything. In review, sorry. All he really owns is this particle burst data that he used to send requests to the Particle Manager. And the Particle Manager will then take that data, distribute it to the particle types, the particle bursts, and the particles to initialize everything, and then it will render them as much as it can. And if it doesn't have the memory to respond to that request, it will throw a warning, which again can be disabled.